Hello and welcome. This is going to be our classwork help video for the worksheet titled Solving Trig Equations in Class Practice. I'm going to try to just skip around and do some of the harder ones here, starting with problem number 1. So one thing to notice is that we're only solving on the interval from 0 to 2 pi. This makes our life easier because we don't have to do how should I write this? At the end of our problems, when we normally write plus 2 pi n, we don't have to do that. That's about all it saves us, but when we're doing this many problems, that is nice to be able to skip that step right there. Okay, when I'm solving, my whole goal is to get it down to trig function equals a fraction. And in order to do that, I've got to combine like terms. For example, in problem number 1, this minus 2 cotangent theta can be canceled from both sides. So that's helpful. And then I want to move the numbers to one side and the trig functions to the other side. And then if factoring needs to happen, I want to get rid of any squareds so that I can just maybe do the zero product property to get down to trig function equals a fraction. So I'm going to move this cosecant to the other side. I'm also going to replace the cotangent with a cosine over sine. So now I've got, after I do all those steps, 0 equals square root of 2 cotangent sine. Now this is plus 1 over sine. And now I can get rid of the signs because sine is on the bottom of everything by just multiplying both sides by sine. 0 times sine is still just 0. But these signs cancel out. Feels a little bit sneaky to cancel out the signs, but the trick was it was on the bottom of every fraction, so it can just go away. I'm going to keep going down because I want to get to problem number 2 here. So we'll skip number 3. Hopefully that one wasn't too difficult. I want to subtract 1 from both sides. I get negative 1 equals the square root of 2 cosine theta. Maybe I'll start writing the theta again. Divide by the square root of 2. Negative 1 over root 2 equals cosine of theta. We don't need to rationalize the denominator here. We can just go straight to our unit circle and draw in our two triangles that have a negative adjacent, because this is adjacent over hypotenuse. That's what cosine stands for. So the adjacent is negative 1, the hypotenuse is square root of 2. We should recognize this triangle as our 1, 1, root 2 triangle, which is a 45-degree triangle, meaning that these angles here are 3 pi over 4 and 5 pi over 4. And that's all we have to write. Theta equals 3 pi over 4 and 5 pi over 4. We don't have to do the plus 2 pi n to both of these because we just want the answers that are on within one revolution of our terminal side. Okay, problem number 2. So when I see a sine squared and I also see a cosine, I'm thinking about doing this. And I don't even know if this is going to work out, but I've got a good feeling that if I replace that sine squared with a cosine squared using the Pythagorean identity, then I'm going to be able to do some factoring with this cosine over here. So let's just see if it works out. I already looked at this problem once. It's kind of a tricky one, so let's make sure this works. So I'm going to subtract cosine squared from both sides. Sine squared equals negative cosine squared plus 1. So that's what's going to replace this here. So negative cosine squared plus 1 minus 2 equals 2 cosine theta. I'm skipping writing the theta for right now. We're going to subtract this 2 cosine from both sides as well as combine our like terms. It's supposed to be a 2 cosine. So we got negative cosine squared minus 2 cosine minus 1 equals 0. Divide everything by negative 1 to make this easier to factor. Cosine squared plus 2 cosine plus 1 equals 0. And this is going to factor into a cosine plus 1 squared equals 0. We can take the square root. Now start writing the theta again. Cosine of theta plus 1 equals 0. Square root of 0 is 0. Minus 1 minus 1. Cosine of theta equals negative 1. This is one that's a pretty good one to memorize. There's only one spot on our unit circle where the adjacent is equal to negative 1, and it's right over here. That way the adjacent is negative 1, the hypotenuse is 1, and that is the angle of pi. So theta equals pi, and that's the only time that happens. This would be a pretty good one to plug back in to just make sure, because when you're at those multiples of 90 degrees, you can end up accidentally dividing by 0 somewhere. If I plug this back in, I'm pretty sure it's going to work. Let's see. Sine of pi, I think I should know that. Sine of pi is, in the right mode, 0. So 0 minus 2 is negative 2. Cosine of pi is negative 1. So negative 2 equals negative 2. It checks out. Okay, probably going to use a very similar technique with number 4 here. Either pick the cosine squared or the sine squared to replace, but probably do the cosine squared since we have the sine over here. And then it should factor. Again, you start with the Pythagorean identity and then you replace it. This one looks like it'll factor. Maybe, which of these might be a little bit more tricky. I'll set up 6. We'll see if this one gets very difficult. I see I've got sine, sine squared, and a cosine squared, so I'm going to want to replace that cosine squared. So sine squared plus cosine squared equals 1. Subtract the sine squared from both sides. I get cosine squared equals negative sine squared plus 1. That'll come in and replace right here. So 3 sine theta plus sine squared theta equals negative sine squared theta plus 1 minus 2. Let's add the sine squared to both sides. And then this here becomes a negative 1, so I'll add 1 to both sides as well. And let's see what we get. I'm going to try to write this in standard form. So 2 sine squared theta plus 3 sine theta equal plus 1 equals 0. I think I did that all right. Now let's see if we can factor this. So I'm going to set up simple factoring. 2 sine theta plus something times sine theta plus something equals 0. That way I'll get my 2 sine squared back. I need to get, these have to multiply to be a 1, so do negative 1 and negative 1, or positive 1 and positive 1, but it's the positive 1 and positive 1 that helps me add up to be a 3 sine, because I'll get a sine and a 2 sine together, that makes a 3 sine. And now, zero product property this. So I'm getting rid of 8. So I can finish this one. 2 sine theta plus 1 equals 0. Sine theta plus 1 equals 0. Minus 1 minus 1. 2 sine theta equals negative 1 divided by 2 divided by 2. Sine theta equals negative 1/2. Now I can label this as opposite over hypotenuse and try to draw this. So to get a opposite that's negative, I have to come down from the x-axis. So these are my 2 triangles. Opposite's negative 1. Oops. 2, hypotenuse is 2. This looks like my 1, 2, and the square root of 3 triangle. Meaning that and there's the 30 degree. So this is 7 pi over 6 is that angle, and 11 pi over 6 is that angle. So those are two of my answers. And when is sine of theta equal to -1? When is my opposite equal to -1? That only happens once right there, and that is 3 pi over 2. So theta equals, and I'm going to put these in order, 7 pi over 6, 3 pi over 2, and 11 pi over 6. Let's see how we did on, that was problem number 6. Problem number 6. 7 pi over 6, 3 pi over 2, 11 pi over 6. Yep, we got them all. Okay. Other tricky ones. I mean, our techniques are going to work for all of these. There's no squareds in these ones, so they should work out decently. That should factor. Number 9 looks kind of tricky because I've got sine and cosine, but neither is squared. So I'm going to struggle to use the Pythagorean identity, but I could use a different identity. I'm going to divide both sides by 2 sine to get started. And so this here is going to be square root of 3 over 2, but cosine over sine, that's the same as cotangent of theta, plus 3 over 2, but sine divided by sine cancels out, equals, and this side is now a 1. Be careful not to replace that with a 0, that'd be an algebraic mistake. Now I've got it down to just cotangent. I can move everything to the other side and solve. So let's do that. Minus 3 halves, minus 3 halves. So now I've got square root of 3 over 2, cotangent of theta equals -1/2. I'll just go over here because that one's pretty easy. Multiply both sides by 2 over root 3. So now I've got just cotangent of theta equals, the 2's cancel out, -1 over root 3. I can label these now. Tangent is opposite over adjacent, so cotangent must be adjacent over opposite. And how can I draw this into my coordinate plane? The adjacent needs to be -1. And then the opposite needs to be a positive root 3, so it needs to come up over here. Now we've got -1 root 3. But that negative can move to the bottom. This is the same as 1 over negative root 3. So my adjacent is now a positive 1. My opposite is a negative root 3. And I get the angle 180 degrees further along here. We can label the hypotenuse with a 2 now because we know that this is our 1, 2 square root of 3. This must be our 60 in here, meaning this is 2 pi over 3. And I think full revolution be 6 pi over 3, so 5 pi over 3, I believe, for that angle there. So 2 pi over 3 and 5 pi over 3. This will be a good one to double check for number 9. 2 pi over 3, 5 pi over 3. Okay, quick scan for any others look particularly tricky. I gotta say the rest of them, they look like you can do them with those techniques. If there's another really difficult one in here, submit it and I'll include it in my Friday video. But hopefully that's enough to get you going. Keep practicing these. Have a great